Let's create Pong in Unity. To start off, go ahead and make a new folder in Unity projects called Pong. Open up Unity. In the Unity editor, make a new project. Create new project. Browse and go to the Pong folder in Unity projects. Select folder and create. Now, let me just start off by saying we're going to be making a game in 2 dimensions, but I'm not personally familiar with how the 2D works. I don't think it's actually terribly difficult, but for now we're just going to be making a 2-dimensional game in 3 dimensions, and hopefully maybe we can transition to the 2-dimensional later. So I want to start off by creating 2 paddles. Go ahead and change the position of the camera to 0, 10, 0. That's going to be important later. Alright, and go ahead and create a new cube. Before we do anything else, go ahead back to the main camera, change the projection to orthographic. Okay, so go to the main camera, change the projection from perspective to orthographic, change the size to about 12, change the rotation, it should be 0, change the rotation to 90 for X because we want it to be facing down. Perfect. So now take the first cube and we want to move it. I'm also just going to kind of flip my screen around because we're going to want the scene to be fairly symmetrical to the game pane. Alright, that's probably good for now. And let's put this cube at 0, 0, negative 10. Perfect. Press Ctrl D to duplicate it. Take that cube and put it at 0, 0, 10. Perfect. So we're going to call this cube player. We're going to call this cube enemy. So let's resize them a bit. So change the scale from 1:1 to 5:1 for both of them. So now they're actually starting to look like, actual panels. So if we play the game, it's pretty drab right now, and there are a few reasons for that. So let's add some color to it and some texture. So when we make a new material, we can put it in a new folder called prefabs. So let's make a prefabs folder. We can put all our prefabs there. Right-click, create new material. Call this player material. And in the inspector, you'll see all this stuff. So next to the dropper, click this color, and let's pick a color for the player. How about green? Like a greenish blue. Yeah, it looks good. That was good. Pick that. Then, if you press Ctrl D, it allows us to makes the process a bit. Alright, and double click if you want to change the name, but this sort of expedites the process just by duplicating the old material. Okay, we'll call this enemy material. Cool. And then let's change enemy materials to something more sinister, like red. There we go. So if you look here, that's what the enemy is going to look like, and that's what the player is going to look like. Drag the player material onto the player object. Drag the enemy material onto the enemy object. Now you'll notice that this looks slightly different in the scene than it does in the game. And that's because the game doesn't have any directional light yet, so go to Game Object, Create Other, put a directional light in your scene, and just go ahead and So next, let's add a ball to the world. So let's create other sphere. And we want it to be placed directly in the center of everything. So this is at 0, 0, -10. This is at 0, 0, 10. So we want to put it at 0, 0, 0, measured from its own origin. Great. So let's press play, see what this looks like. Great. So now go ahead and create a new folder, call this one scripts. So we actually want to make our game, interactive and have it do stuff. So create new C# script and call this one player controller. And open up player controller in your favorite development environment. Or mono develop. So, in mono develop, in the update function, we're going to instantiate a new array, and I'll explain what array is in 1 second. Mouse, lowercase or, yeah, it's lowercase, mouse position. There we go. So let me explain what's going on here. Basically, array is a line with a direction, so it's like a vector, pretty much. Now, camera.main.screen points array. So you're saying, basically, you want this array to have a value of whatever the screen is pointing to. And it's right now we want it to point to input.mousePosition, which means we just want it to point to our cursor. This is going to be important later. I'm going to give this a different name, though. This is a bad name. Call it ray position. That's better. I really don't like naming objects. I don't like I don't like our identifier to be the same as the name of our object. That seems a bit tacky. So go to the next line. And now we're going to transform the position of the player. So we say transform.position gets new vector 3. And we'll say ray, or we'll say ray position dot gets point, passing in a parameter of 10f of x, comma. We're going to make this 0.0 floats and transform dot position dot z. So let me explain everything that's happening here. So the positions of this vector, ray position dot get point and point x. Essentially what this is doing is it's saying that we just want to multiply whatever the x position is of this point by 10f. We don't want the y to change. So if we go back to our Unity editor, you'll see that we don't actually, when the paddles are going back and forth, we don't actually want the y position to ever change. So y can simply just be 0. That should be a lowercase t. We could theoretically actually make this 0 as well, but transform.position.z is fine as well. So go ahead and save this script and attach this script to the player. Just make sure it's on there. Yep, looks good. Now press play and see what happens. Check that out. So now, wherever our cursor moves, the paddle will follow it, but only in the x direction. And that's important. So it's not actually changing the y position. So I can move my cursor to the top of the screen. I can move my cursor to the bottom of the screen. It's not going to affect anything. That's important. So perfect. That's exactly what we wanted to happen. So why don't we also start adding some other things to the world? Oh, first of all, let me just rename the sphere ball. That's what was going to be it. It's a ball. Let's add some walls to the world. So to do that, go ahead and create a cube. Move the cube over here, and let's resize it. So let's make it. We can make it wider, bigger than that, even bigger than that. Let's try that. Perfect. Then we'll try. We'll make it wide. Yeah, that looks good. Maybe a little less wide than that. Maybe like 3 wide. Yeah, I think that looks okay. So position it at -10, -4, and 0. Yeah, we'll move it back a little bit. Okay. Then we'll just duplicate it, and we'll drag this new one over here. Let's see, this is at -10.34, so let's make this one at 10.34. Awesome. Alright, so these are our walls. So we're going to call this one wall left. We're going to call this one wall right. And essentially what's going to happen is we want our ball to just be able to bounce off of each of these walls and then hit the paddle and so forth. I don't really like this white color though, so why don't we make a new material and call it wall material. So go over to this color dropper here and maybe make it like black or something. I think that looks going to look good. Wall material, drag that onto wall left and wall right. That looks okay, yeah. So if you don't notice, our paddle kind of goes to the wall right now, so later we will change that. So let's add some physics to the ball. So go to ball and go to the inspector, add components. We're going to add a physics component, and we want to add a rigid body component. So this gives it things like mass and drag. Well, let's just see what happens when we don't change anything. So if we play it, let's not maximize. When we play it, you'll notice that the ball will drop, and that's because use gravity is checked. So it's going to fall in the y direction according to kinematics. So go ahead and uncheck that ball, use gravity. We're going to go to constraints, and we want to think about like what are the constraints that we want. In what directions do we want it to move, and in what directions we want it to rotate? So we don't really want it to move at all in the... So the x direction is fine, the z direction is fine, but we don't actually want it to move in the y direction. So we're going to have him freeze that position. And we actually don't want it to rotate in the x or z direction. So let's make sure that's in the right place now. Okay. So press play. Great. So now that's not going to do anything. Alright, so now add a new script to your scripts folder called ball controller, and this is what's going to determine the behavior of the ball. And this is where we're gonna have to use some physics and some math here, but nothing you can't handle. Just some basic kinematic stuff. So the first thing I want to do is make 2 variables. The first one is called invert. And I want to make another one called towards player, starting it at 1. Alright, and the point of these are, well, you'll see. So we're going to start invert at 1. And basically invert is telling the ball in what direction it should be going in the x direction. So for example, when it crashes into a wall, it should be going in the opposite direction on the x-axis. So invert keeps track of what direction it should be going to. So every time it hits a wall, essentially invert is, well, inverted. Then we'll start off towards player at 1. And we'll add this rigid body dot velocity and we'll make it a new vector 3, 10.0f, 0.0f, 5.0f. So basically what this is doing is it starts off in the x direction at 10, the y direction at 0, and the z direction at 5. So imagine a vector created by that, and that's the first velocity vector that will be created. So we're using rigid body because this allows us to use kinematics to make our project interesting. So why don't we save this and make sure we attach the ball controller to the ball object. Press play and see what happens. Well, something happens, but so it looks like it sort of escapes the confines of our Pong game universe. So while we celebrate its ability to transcend its reality, it's still here. So we want it to stay here. To test for collisions, we can add a new function. We'll call it void on collision enter, and then we'll pass a parameter collision. We'll call it ball collide. And we can say something like this: if ball collide dot game object dot name is equal to wall left, or ball collide, well, it's actually just going to be this except wall right. So I want to explain this entire conditional statement. So what we're saying here is whatever the block statement is going to be, if a collision is detected, so if we detect a collision between the ball and some game object with the name wall left, or we detect a collision between the ball and some game object with the name wall right, then for now we'll just say print I hit a wall. So let's go ahead and, actually we're going to get an error. We should have an extra curly brace, so let's get that done. Then save it. So let's see what happens then. And it looks like we need to change the y components of wall left and wall right to 0 because they will not collide otherwise. So let's press play now. So make sure that collision is spelled correctly in on collision enter. Otherwise this will not work. On collision enter is an overridden method. So go ahead and press play now and see what happens. Cool. Now it works. So maybe we can add one more thing to the game before we get done with this particular video, and then we'll have a part 2 video to finish everything else up. So go ahead to on collision enter, and where it says if, here, instead of printing I hit a wall, the idea here would be that we want to invert its x direction. So now take this out and instead say invert gets invert times -1. So essentially we're just inverting the value of invert. Then we have rigid body dot velocity. So it's the same thing we had up here, except we're going to be giving it some slightly new values. So rigid body dot velocity dot get new vector 3. We're taking a 10.0 float times invert -5.0f times towards player. We'll change this to -5.0f as well, so it goes towards the player. So if everything works correctly, let's see what happens. Cool. So now it actually hits a wall, and when it hits the wall, well, it's not working exactly how we want it to, but we can make it work a little bit better. Because now we need to add behavior for each of the paddles, because right now it doesn't have behavior for the paddles. But for now, that'll do for now.